One.
Alright guys, in the last lesson we talked about solving systems by elimination and substitution, and I mentioned that there was a third way, and that was graphing. We're going to focus on linear systems of equations today, and specifically look at how to solve these by graphing. Now, you could solve both of these, or all the examples today, by substitution or by elimination, but we will specifically talk about how to graph some of them, because sometimes that's a requirement. So the solution to a system is the point or points that makes both equations true. In other words, it's where the graphs of the equations overlap, where they intersect. They can either have one solution, they cross at one point, no solution, they're parallel and they never touch, or infinitely many solutions, they're the same line graphed on top of each other. On a graph, the solution to a system can easily be seen. It's the point of intersection that's highlighted here. It's important. Okay. Some key concepts here. I'm not going to read through all these, but this is the graphing method, and some steps you want to look for when you're trying to graph. We'll go through some specific ones as we do the examples, but these are in your notes. Make sure you read them. So here's the three different types. This first one right here, you have a single solution, okay, it's where they intersect. Here you have no solution. And in this third one, it looks like you only have one line graph because it's literally the same line. It's always on top of itself. So there's infinitely many solutions. Any point that falls on that line is a solution. Now, any point that's, when it says infinitely many, that doesn't mean every solution is a solution, right? So like a point that's over here, like that point, would not be a solution. It's any point that falls on the line that's graphed, okay? Which does still mean there's an infinite number of them, but it doesn't mean that every point is a solution. All right, so example one, graph the system, then determine whether the system has one solution, no solution, or infinitely many. So the first thing that you're going to want to do is make sure they're both in slope-intercept form, or you can use the y-intercept. We'll talk about how to do that a little bit more in just a second. But the traditional way to get this done is to take the first one and solve it for y. Okay, so we have 4x minus 6y equals 12. First thing we would do is subtract 4x, putting it in slope-intercept form is the goal here. So we have negative 6y, and slope-intercept form means the x term needs to come first. So negative 4x plus 12, then divide by negative 6 on both sides. We get y equals negative 4 over negative 6 reduces to positive 2/3. And then 12 divided by negative 6 is negative 2. All right, so now I have this, and I have this. Okay? Those are the two equations that I'm going to graph to see what actually happens. All right? So, I'm going to write both of those down again. We have y equals negative x plus 3, and y equals 2/3 x minus 2. All right, so what does this look like? Let's make sure we get our graph down. Let's try to keep it in the first quadrant and see if we can do that. So we're going to count by 0, 1, 2, and I'll only put those for now. If we need to add more, we can. 0, 1, 2. Okay, so for this first one, we're starting at 3. Let's probably do start at 3. And it has a slope of what? Negative 1. So down 1, right 1. Okay, so it's a negative slope or descending slope. Alright. And let's see if it'll show up there. The next one starts at negative 2. Okay, so I am going to at least need to go down into negatives a little bit in order to graph this one. Alright, so that would be negative 1, negative 2. So that would be the intercept there. And the slope here is up 2, right 3. So up 2, right 1, 2, 3. And that should, up 1, 2, right 1, 2, 3. That should kind of give you an idea of where these two things cross. Okay, so the solution to this has one solution. That solution is 3, 0. If you plug that in, right, you should get that it works for both of them. So if I plug in 0 equals negative 3 plus 3. Okay, so I get 0 equals 0. That works. If I do 0 equals 2/3 times 3 minus 2, 3 and 3 cancel, and 2 minus 2 is 0. 0 equals 0. So that is indeed the correct answer. It works for both. Alright, now we're going to move on to a couple more examples.